Okay, hi class. I know a lot of you guys are not going to be in class today, so I'm going to record this lesson and then just listen to it sometime over the weekend. This lesson should not take too long. It's just basically about devising certain simulations and yielding results based on those simulations, okay? So here's what we're going to do, is we are going to do lesson 38.1. There is an arts and crafts type of thing in this section. I'm not going to require you to do it, but if you would like to, be my guest. It'll be a good time, okay? So we're going to talk about devising simulations these can basically help determine when you observe certain data, whether or not it's consistent or inconsistent, and then we want to make connections between the data that is generated. Okay. If you're looking in your books, this is going to be on page 593 of your books. Okay. So let's get started. Okay, so for those of you who like video games, that's what we're going to start off with, okay? So it says, Martin enjoys playing video games. On his birthday, he received Man vs. Monsters, a game in which the players play the role of a person who is trying to save the Earth from an invasion of alien monsters. At the end of the game, the player either wins or loses. The first 3 times Martin plays the game, he lost. In the next 7 games he played, he won 4 times, and he felt like his performance was improving. In fact, the sequence of Martin's wins and losses is followed where L represents losses of games, and then W represents wins of games, okay? So obviously what we have is that he lost the first 3 times, so those are 3 losses. Then he won 1, 2, 3, 4 out of the times from the last 7, okay? So we have this data set that looks like so, okay? Okay, so this is kind of where we're going to do the arts and craft thing, okay? So just talking about what a simulation is, okay, he's basically what Martin is doing is a simulation. So he says that he concludes that he's getting better at the games and the more he plays. And he said that the sequence of wins and losses was evidence of his improvement. He has a sister, Hannah, however, who's not convinced. She said that the sequence of wins and losses looks like a random list to me. If you were really getting better, why did you lose the first 6 and then win the last 4? Okay, so in this activity, we're going to use the simulation to decide who's correct, Martin or Hannah. Okay, so here's where... Okay, I'm gonna say this. There's a chart on page 595 of your books where it has losses and wins. Okay, basically what you want to do is those are 10 squares. You can cut them up. Okay, I'm not gonna require you to. Okay, and then basically you're gonna place them face down on your deck, and then basically kind of randomize it based on that. Okay. If you choose to do this activity, you're going to mix them up and arrange them so that you do not know which ones represent wins and which ones represent losses. Then turn them all face up to see the loss or win and write down the order of wins and losses here. Okay, so let's say if your cards were mixed up, okay, let's say if they went in random order, it went loss, win, loss, win, loss, win. He only won 4 times, so that's... And then 1, 2, 3, 4, 5, 6, 7, 8, and then loss. You could have a sequential order like that. There's millions of other possibilities, okay? It's not just the one I listed above. Actually, if you want to try to find the number of possibilities, it would be 2 times 2 to the 10th squared. I'm sorry, not 2 to the 10th would be the number of possibilities, okay? Okay, so now we're going to look at specific types of sequences that appear. So it says, consider the following 2 sequences and write a sentence explaining whether it appears Martin is approving. Okay, the biggest thing in this is that order does matter. Okay. So we're just kind of observing what we have. So in part A, there's 4 losses, 1 win, 2 losses, and then 3 wins. Okay. So if we are looking at, is Martin improving? Well, he started off with 4 losses, and then he ended with 3 wins. So I would say since he had 3 wins right in a row, it appears that, yes, he is improving. Okay, we kind of want to see wins towards the end. Okay, and then for part B, he wins 1, loses 1, wins 2, loses 3, wins 1, and then loses 2. Again, you're looking to see if there's wins at the end, and what you see is actually you're going to see 2 losses at the end, okay? So that's going to be no, he is not improving. He's actually decreasing his skills because he's not winning, okay? So this is all told from just an observation. It's not necessarily mathematically explained. So we're going to figure out a way to mathematically explain how he's improving. Okay, so it says if it is desirable to quantify, measure with numerical quantity, the extent of which a sequence of win or losses indicates that a player who achieves is really improving, describe a method that may quantify the results of players playing 10 games such that the number describes the improvement of players, and we want to be creative. So these can be any way, basically, it can be anything, okay? So we want to somehow quantify this amount, okay? The coolest way that we could do this is by just counting up the probability of wins compared to the total number of games. Okay, that's the easiest way of quantifying something. You could also say the fact that depending on how long Martin plays the games, you can quantify it from the number of hours to the number of wins that he's getting. You could also talk about how he's getting help from a friend. Anything that hints at the idea of improvement would be a fine answer for this. Okay, so the total number of games. Okay, that's just one option. Okay, there's many other options. Again, you just have to figure out one. Okay. Okay. So here's one way of kind of quantifying what we're seeing, and it's what's known as an improvement score. Okay, so one of these ways to quantify improvement is to count how many wins occur amongst the last 5 games and subtract it from the number of wins that occur among the first 5 games. We call this an improvement score for the sequence of results for 10 games. Okay, so if we were looking at these 2 examples, okay, basically what we want to do, it says find the improvement score for each, and we want to show our work. Okay, what it says is count how many wins occur amongst the last 5 games. So if we were to look at the last 5 games, it would be those right there. Okay? How many wins occurred there? It would be 3. Okay? And then what we're going to do is subtract it from the number of wins that occur amongst the first 5 games. So if I was looking at the first 5 games, be the first ones, that would be 1. So it would be 3 minus 1. That would be 2 as an improvement score. Okay. Pause this video right now. Try the second one to find the improvement score. Okay, so if we're looking at finding an improvement score, we're looking at the last 5 games subtracted from the first 5 games. Okay, so the last 5, the wins, there's only 2 wins, so it's going to be 2 minus the first 5 games. There was 2, so it has an improvement score of 0. Okay, now, why do you guys think we start with the last game? Think about it in this way. If we were looking at the last 5 games, okay, that's where we're kind of wanting to see more wins than losses. That's why we start with it, okay? We subtract it from the first 5 games because that's where we started, okay? So it's the end minus the start, and that'll give you your improvement score, okay? Okay, so if we were to look at, okay, these 2 numbers, the first one is a positive number, and the second one is just 0. If we were to use this method constantly, we will want to ask ourselves, what would a negative improvement score imply? Well, essentially, what a negative score would mean, okay, would mean that the wins from the last 5 games would have to be less than the wins from the first 5 games. Okay? So if you only had 1 win at the end and then 3 wins at the beginning, you would do like 1 minus 3. That would give you like a -2. Okay, and guess what? What would that show is that you're not improving. A negative value means that you're actually decreasing in improvement. Okay, and then what would the positive improvement be? Okay, well, that would just be basically that would just basically mean that this is going to change to now the wins from the last 5 games is greater than the wins from the first 5 games. Okay, so not too bad. So what do we call that number that we computed? Okay, well, if we're talking about statistics, okay, any number that summarizes the data in a meaningful way, and meaningful way is used very like vaguely, like what is meaningful. Okay, we call that what's known as a statistic. Okay, so your improvement score is the number of which is the difference between the number of wins amongst the last 5 games of 10 and the number of wins amongst the first 5. Is a statistic because it summarizes the data with the number that can measure improvement. So statistic and the improvement score are equal. Okay, so if you were to do the first part, okay, meaning like mixing up all those cards, okay, let's say we had a simulation where, and I'm just giving an example, you can look at your own, okay, let's say we had, okay, a loss, a win, a loss, and then we had a win, a loss, a win, and a loss, okay? What I would do, and then one more loss. Okay, what I would do is calculate the first 5. The number of wins would be 2. And then the last 5 would be 2. You're just doing 2 minus 2. Your improvement score and your statistic would be 0. Okay, so again, this is from shuffling up the deck from before. Okay, okay. Getting towards the last part, okay? So it says, recall the reason for computing the improvement score. Martin's sister Hannah is skeptical that Martin's ability to win the game is improving. She thinks that a particular sequence of wins and losses looks random and does not imply improvement. To address her concern, it is important to determine whether a sequence like Martin's might easily show up in the order of wins and losses really in random. More specifically, it is important to determine if the improvement score that results from Martin's sequence of wins and losses is the number that might easily result from a random arrangement of 4 wins and 6 losses. Okay? So we want to compute the improvement score for Martin's actual sequence of wins and losses. So this is not randomized. Okay? Because if it was randomized, the improvement score would be affected. Okay? So if we are looking at the last 2 or the last 5, how many wins would be there? It'd be 3. And then the first 5 would be 1. So you would do 3 minus 1, which is 2. Okay. Again, we're just subtracting, okay? I always have to tell you how to find your improvement score, so you can never just say, oh, you just take the first 5 and the last 5, okay? It doesn't work like that, okay? All right, any questions? If you have any questions on any of this stuff, it's just basically improvement scores and figuring out how to calculate that, okay? All right, so, okay? Here's what we're going to do, okay, is for Monday, after the quiz, when you guys have time, I want you to do 9 and 10, and then I'll give you 5 points for doing this, just to make sure that you guys understand. But yeah, I think that's pretty much the lesson. It's really quick. If you would like extra practice, it's 38.1. You can look at it throughout the weekend. Okay. The main things I want to focus on are the announcements. So we do still have the quiz on Monday for activity 36. Practice check 36 is going to be also due on Monday. And then I've opened up practice check 37. It's really quick. It's like 8 questions. That will be due on Wednesday. So just make sure that you're paying attention to all 3 of these. And then, yeah, we're almost done through the year. We're like a couple more lessons away from finishing Algebra 2, okay? So we're getting there. If you have any questions, email me, but you guys can sign off. Thanks.